Good morning, class. Today we are going to discuss linear equations, different forms of linear equations, and how you can get the different key points that you need from a word problem. Okay, so here is a word problem. You are saving money to buy Christmas gifts this year. You already had $50 and plan to save 5 more each week for the next several weeks. Okay, so we are going to do 3 different things. We're going to create a table, then we're going to create a graph, and then we're going to find an equation for this pattern. So the first thing I'm going to do is create a table, which means I need to have an X and a Y. And I'm going to let my X be the independent variable, which in this case would be how many weeks. Okay. And my dependent variable, which is y, I'm going to let that stand for the amount of money that we save. This step right here is called defining the variable. So everything that we do, we know that x equals the number of weeks and y equals the amount of money saved. Okay, so let's read this again. You already had $50. So at week 0, when you begin to save, you already had $50. And you plan to save $5 more each week. So after 1 week, you now have $55 saved. After 2 weeks, you now have $60 saved. After 3 weeks, you now have $65 saved, and so on. From our graph, in order to create our graph, we should label. So down here on the x-axis would be number of weeks. And we are counting by ones on that scale, so this would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then on the y-axis, we have the amount of money saved in dollars. And those numbers are larger, so we're not going to count by ones, but we do still need to start at 0. So it looks like we want to count by 5s, because we're increasing by 5 each time, but we also need to be able to get to 50 at least. So let's see, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, so if we count by 5s, 5, 10, 15, and then I'm going to skip. We can definitely make it to 50. And then 55, 60, 65, 70, 75, 80. So we can go all the way up to 80 on this scale, which I think should be enough. Okay, so let's plot our 4 points that we have here. We have 0, 50, 155, 260, 365, and then we can continue this pattern because we know it's going to increase by 5 each week. And the longer you save, the more money you're going to have. So this is a linear function, forms a straight line, and it passes the vertical line test. Okay, so that's part B. Part C is going to be our equation, which we could have started with our equation because the fact that they give us that you already had 50 is our y-intercept, and then it's $5 more each week. That's our slope. So our y-intercept is 0, 50, and our slope is $5 for every 1 week. Okay. So our equation, if we wrote it in slope-intercept form, would be y equals 5x plus 50. Now, since this is a function, we could also write this in function notation. F of x equals 5x plus 50. Okay, so here's a little review of some pattern stuff. This is all stuff that you should have learned last year. And then obviously we will continue to discuss every year. You'll use this in Algebra 2, you'll use this in Trig, Pre-Calc, some geometry. So now we're going to review some of the formulas. Okay, so the slope is a rate of change, and it is specifically the change of the y variable divided by the change of the x variable. And as you can see here, our slope was a change of $5, an increase of $5 every 1 week. So really this has two labels. Okay. There is a different way to write this. Change of y, they use this little triangle which is called a delta. Delta y over delta x means change of y over change of x. You might have also heard of this as rise over run. Means the same thing. And there is also a formula, which would be y2 minus y1 over x2 minus x1. You can also see your slope pattern in a table form. So over on the right side of this table, you can see what's happening. There's an increase of $5. And on the left side of the table, there's an increase of 1 week. This is the change of the y-axis, and this is the change along the x-axis. So again, we would put them on top of each other, 5 over 1. Okay. The y-intercept is called the b value, lowercase b. Actually, I forgot to tell you the slope. The slope is called the m. And this is an initial value or a starting point. And this is always a coordinate where 0 is in the x variable spot. And then you can find what the b value is, or the y-intercept. And from the picture here, it's always along the y-axis. There is such a thing as an x-intercept, which is a point along the x-intercept or x-axis, and the y value is 0 instead, but it's not really important for our equations. It's just another point that we like to find sometimes. Okay, point slope form. Just like it sounds, you need to have a coordinate, like an x, y value. We're going to call it x1, y1. You also need to have a slope, which is your m value. If you have these two things, but you don't necessarily have your y-intercept, you can write an equation in this form. Y minus y1 equals m times the quantity x minus x1. So for example, we have our 0, 50 up from here, and we also have our slope. So we could have written y minus 50 equals 5 times the quantity x minus 0. That's the same equation as the one from our example above. It's just in a different format. So we could distribute here and get y minus 50 equals 5x minus 0, and then add 50 to both sides to solve for y, and we get 5x plus 50. Same equation, just a different format. And this form is slope-intercept, which is, of course, y equals mx plus b. In order to write this form, you need to know the slope, and you need to know the y-intercept point. Just like we did up here, we knew the slope, we knew the y-intercept, so we can just substitute those in. And of course, like I just said, you can get this form from any point and a slope. Okay, our last form of a line is called standard form, which the formula for it is this. Capital A times X plus capital B times Y equals C, where A, B, and C are integers or real numbers. So let's see, in our case right here we have y equals 5x plus 50. If we take this 5x and we subtract it on both sides so that we move it to the left side of the equal sign, we would get negative 5x plus y equals 50. This is standard form. Okay, so we have three integers here. Our a value would be negative 5. The b value would be our invisible 1 right here. And our c value would equal 50, which is over here. That's the constant term. So wherever you start from with a line, you can always get to all the other forms just by doing some algebraic properties and doing things on both sides. Okay, let's try some examples here.